Alright, on to question number 3. Now, this is the question that I have some beef with. You know, I have a score to settle with because when I first attempted the 2018 paper, this was one of the questions that I lost marks on. I only lost like 5 marks. I scored 95 for the first try, but this was the one. Okay, so I want to make sure that I clearly explain to you how to do this one. All right, so let's go. For a recycling project, Ali collected 17 bottles. Okay, Bala collected 2M bottles. Okay, let's just underline this. And Carl collected 2 plus M bottles. Each of the statements below is either true, false, or not possible to tell from the information given. For each statement, put a tick to indicate your answer. Alright, so let's take a look at the first statement. Ali collected the most number of bottles. Now, this one is quite simple. Ali collected 17 bottles, right? So we know, I'm going to write this down so that it's easier to see. Bala collected 2M bottles. And Carl collected 2 plus M. Okay, so for this question, Ali collected the most number of bottles. Now, is it possible to tell? The answer is 17 here, right? 2M. Okay, let's make M into a number that is, let's say 1, 2, 3. Okay, let's say 2 times 1. The answer will be 2, right? 2 times 2, 4. 2 times 3, 6. As you can see, the number is rising. Therefore, the moment I cross which number? The moment I cross 9, right? 2 times, I cross 8, sorry. I go to 9. 2 times 9, suddenly, Bala has what? 18. He suddenly has more than Ali. So it's not true that, Ali has the most number of bottles, right? So is it possible to tell? Because when we go from 1 to 8, Ali has the most number of bottles, more than bottles, but when you come to 9 and above, what happens? Bala has more bottles than Ali. So it's going to be a question that is going to be a statement that is not possible to tell, okay? So let's look at C on the other hand. C is 2 plus M, so 2 plus any number, right? So in this case, if we were to put 1, 2, 3, the number will also steadily rise. So for numbers below what? Let's say 15, right? 15 will be 15 plus 2, 17. Let's say M is 15, then they have the same number. The moment you cross 15, you got 16. 16 plus 2 gives you 18, and suddenly Ali no longer has more. So like I said again, 1 to 15, no problem, is still, I guess the same number of people, number of bottles. But the moment you cross 15, you go to 16, boom, the number becomes more than Ali. So as a result, you cannot say it's false, because why? It is true at the first half, right? 1 to 8, 1 to 15, that Ali collected the most number of bottles. But the moment you cross that number, boom, it's not possible to tell. So that's the answer for the first one. Okay, Bala collected more bottles than Carl. Okay, Bala collected more bottles than Carl. Now, this was the one that I had a mistake with, right? So I thought to myself, okay, 2 times of M is always going to be more than 2 plus M. Isn't that true, right? Because 2 times of 1 is, 2 times of 2, for example. Let's try something, a number in my head, 2 times 10, okay? So 2 times 10, 20. 2 plus 10, 12. Confirm going to be what? True, that Bala collected more. But I forgot that the smaller numbers will actually cause me to get the answer to be Bala did collect less. For example, 1. 2 times 1, Bala. Then Carl has 2 plus 1. Suddenly Carl has more, 3. Or 2 times 0, you want to test 0 as well, right? 2 times 0 is 0. And Carl has 2 plus 0, which is 2. So you see, you want to try on the opposite ends, on the far ends of 0 as well. All the way to the big numbers as well. So in this case, since you can't tell, the answer will be not possible to tell. And last one, the 3 boys collected 3M plus 19 bottles altogether. Now this one is quite straightforward, right? 17 plus 2M plus 2 plus M. So you take 17 plus, this is a number, plus another number, 17 plus 2 is 19, right? 2M plus M is 3M. So 3M plus 19, that is confirmed true. So the answer to this question is not possible to tell for the first 2 and true for the last one. That was easy. Alright, so this is another one that a lot of children struggle with, okay? They can't really see how to find the area. They can't really see what this is. Now, one of the things that I always tell the kids that before you actually look at the diagram, you want them to read. A lot of them don't read the question in front at the top. So this happens for data analysis, like, you know, those pie chart or those bar graphs, but it also happens for things like this where there are images. I mean, our kids are usually very visual, so they want to look at it first, but they don't read the question. I get so frustrated sometimes. So anyway, two rectangular mats, right? So these are actually what they are, mats. So you can imagine these are mats on the floor, and the floor is 6 meters by 4 meters long. Okay, they are placed on the floor of a rectangular room as shown. Okay, so there's a rectangular room. If you can imagine, there's a door over here. Let's say I'm just going to draw a door over here, just for happiness sake, right? So the mats overlap, right? The mats overlap, and the area covered by the overlap is 5.2 square meters. So basically, there is an overlap area here, and they want us to find what? The question asks you, find the area of the floor not covered by the mats. Okay, so basically we need to find what is this length, and we need to find what is this length, the length and breadth of these rectangle, so that we can figure out the area of the floor not covered by the mats. But like I said, it doesn't seem as easy as it looks. Okay, so since they are the same mats, right, this is 6 by 4, this must also be 6 by 4. Now that tells me what? It tells me that, oh, that's good, I can figure this out. If this is 4 meters and this whole thing is 6 meters long, right, this whole thing is 6 meters long, it tells me that this must be 2 meters. Simple. I found one part of the puzzle. Now, what about the other part of the puzzle? Now, this is the one that's a bit challenging. So a lot of students misunderstood this 5.2 square meters. It's actually just the overlap, isn't it? Right? It's just the overlap from here to here, right? So my fingers are proving to be a lot more steady than the computer. So there you go, right? So I'm just going to do freehand, 5.2 square meters. Question is, how do we find that, right? How do we find that? Remember that this is actually also 4 meters. Okay, if it is 4 meters, all I need to do is find out what is this. Okay, now so a lot of the kids I'll be like looking for, like, oh man, if this is 6, right, and this is 4, how do I find that, right? And the answer is, you don't even look at that, because they give you the area, and area equals to what, right? So once you know the trick to this, it becomes very simple, just like anything else, right? Area is equal to length times breadth, and you have the length. The length is 4 meters. Sorry, I'm very frustrated because I know this question is quite simple, but a lot of kids get it wrong. So the area is 5.2 meters square meters. This is 4 meters. So what's the breadth, right? We just divide lah. So 5.2 square meters divided by 4. Right, so that will give you 1.3 meters. Now I have this 1.3 meters. If that's 1.3, then we can find out what is this, right? This length over here. This whole thing is 6, so 6 minus 1.3 will give you 4.7. And if this is 4.7, we can find the area of the floor not covered by the mats, which is 4.7 by 2. So you see what I mean? Like, it's actually pretty simple once you figure out the area equals to length and breadth, which you learned in primary 3. Sorry, I'm really quite frustrated by how some students are not able to get this question. In fact, not some, but a lot of them. Okay, so the answer here is 9.4 square meters. Done. Okay, so we are on this question, which actually is a heuristic or a problem-solving method that has been taught to your children in primary 4 or primary 5. But because of the way they ask this, is very sneaky, right? It's hard to see that this actually this particular heuristic. Okay, so it's worth going over one more time. It says here that Ken had $15 more than Lisa at first. Okay, so let's just highlight that first. Okay, $15 more at first. Okay, so after Ken gave some of his money to Lisa, so Ken gave to Lisa. Now he had $21 less than Lisa. Question: how much money did Ken give to Lisa? Now the whole idea here is that there is a transfer, right? So if it's a transfer, it's going to be what? Constant total. We've known this from a lot of the heuristics, that when there is a transfer, it's always about constant total. Now, if you just quick recap, a transfer basically means that the money does not leave the two or three of them, and therefore the amount of money, the total, will always be the same. So I'm going to draw the model right now. Okay, so before and after, right? At the start, Ken had $15 more. So I'm going to draw a model like that, and I'm going to draw one more that is smaller. Okay, shorter like that. Okay, so the first one would be Ken. Yes, Ken over here, who has $15 more, so that would be $15. Okay, and Lisa would be here, so that's $15 more. Okay, now this is before, so I'm going to label this as before. Okay, now how about after? What happens after that? Okay, so he says after Ken gave some of his money to Lisa, he had $21 less. Now, how does that happen? Okay, let's draw this. Okay, suddenly Ken had less, right? That looks almost the same. Let's shorten it a bit and lengthen this a bit. Okay, I'm not gonna draw like, you know, a beautiful image, so let's just get over that. But Lisa at the end had Lisa had $21 more, right? Because he said what? Ken had $21 less. Okay, so sometimes these English parts of it, they also not your children get a bit confused. So if you say that $21, Ken had $21 less than Lisa, it means that Lisa had $21 more than Ken. Okay, so this is $21 more. So how did it go from before, whereby there are $15 more, to having $21 less? How did that happen? Now that happened because Ken gave some money to Lisa, right? So a lot of students got this wrong. I'll tell you later why, but let's draw the intermediate model. So what happens in between? So I asked the students, now, in order for Lisa to have $21 more, that means what? Ken had to give all of his $15 and some more money, correct? And the answer is correct. Yes, he had to give all of his money first. So which tells me later on that I would be left with this situation. Okay, take a look. So Ken and Lisa over here is going to have going to reverse their rules for a while. So suddenly Lisa is going to have $15 more, right? Right there. So how does this $15 become $21, right? So this is what a lot of the kids will tell me. They will say, oh, that's simple. Never, when you hear that simple, right? I don't usually have doubts. Okay, so $21 minus $15. So how much is that? So there's a difference of $6. So what needs to happen for Lisa to have $21 more, right? So the answer would just be $6. So Ken has to transfer $6 to Lisa, correct? Wrong. So that's exactly what the kids did. So you see, if I take this amount, right, let's say this one in black over here, and I transfer over to here, right, a lot of the kids tell me that it's actually going to be so simple. So I get $6 over here, and that becomes 21. But they forget that when I remove this part, what happens? Ken's model over here and Lisa's model over here would change to look something like this. How much more Lisa has is no longer just this one and this, it will also be part of this. Does that make sense? So just to make sure you understand this completely, I'm going to draw the model one more time, but this time around I'm going to show you that how it looks like without the that shaded part over there, which happens to be the one that he gave away. So I'm going to draw this thing over here like this. Okay, so watch. So basically after this is the $15, I'm gonna just draw it for you so that it's easy for you to understand what I'm saying and no confusion can come out of this. So that's the 15 that is gone. Sorry, that's not the $15. That is just the part that he has to give away, right? As a result of that, now Lisa would have a lot more. Okay, this was the 15, and then this would be the extra supposedly 6 lah, right? But you see what happens if there's 6 over here, then what happens? This one is 6, right? Give away 6, right? So then he'll be 6. So actually at the end of the day, Lisa would have Let me just label this so that I don't get confused. 15 plus 6 plus 6. What is that? That is 6 plus 6 is 12. 12 plus 15 is 27. 27 more. Is that the answer? No, the answer was 21. Now, that's the reason why we do not, that's the reason why a lot of students make this mistake. So instead of that, right, instead of 6, 6, right, what we need to do is we need to make it in such a way that it will add up to 21. So 21 minus 15 is 6, and the 6 has to be divided by 2 units. You get it? So 6 divided by 2 will give us 3. Now that will lead to this happening. And that's why this is how we do this question. So we get 3 plus 15 is 21, right? So how much money did Ken give to Lisa? So remember, he gave away, the step 1 was he gave away the 15. So this one over here transfers. Let me just shade this so that you know. This $15 is transferred over to here. And this is wrong. Remember I told you this is the mistake. Instead, he transfers another $3 over here. So the answer is 15 plus 3, which equals to $18. Alright, done. Alright guys, we are on question number 7. The pattern on the tile ABCD shows 3 overlapping squares of different sizes. So importantly, first of all, they are overlapping. Okay, they are overlapping squares of different sizes. So you can imagine there's one really big shaded square, there's one slightly smaller white square, and there's one more shaded square, smaller one on top of that. Okay, now the important part they told you here is AF equals to FE. So imagine if AF equals to FE, that means that this is, I'll call this like 1 unit, this is also 1 unit, correct? And now they tell you that AE is equal to ED. So AE, this whole thing, is equal to ED, which tells you that this is also 1 plus 1, which is 2. Now with that in mind, we can actually find the answer to the question, which is what fraction of the tile ABCD is shaded. Okay, so be careful. They're asking for shaded, not unshaded. Okay, don't waste marks just like that. So I'm going to use a different color right now. I'm going to show you the trick to the whole thing. Okay, so if this is 1 is 1 is 2 is 2, right? That means the whole thing is going to be made up of tiny, tiny squares. I'm going to do it right now for you. 1, okay. This is like that. 2. Okay, and let's say somewhere in the middle here. 3. And boom. Take a look at that. Now that is how it's supposed to look like, right? Okay, I'm going to do some magic here. I hope I can do this. Let me see if I can just quickly do this instead of wasting time. Okay, let's see. Boom, there you go. Oh no, I can't rotate this. You know what? Forget about it. I'm just going to do this again bit by bit. It's okay. So let's go. Let's draw the lines for this one. Oh no. What happened? Oh, not again. Guys, save me, technology. Okay, there you go. I'm gonna do this. I'm gonna will this to being 1. 2. Remember this one over here? This one over here has 2 more, right? So 1, 2. Then here has 1 more right there. Okay, roughly, like you can tell basically what I'm doing, right? In other words, they have equal squares and we get a waffle. Waffle. Alright, so what fraction of the tiles ABCD is shaded, right? So you can see straight away that it's 4 by 4, right? You don't even have to draw this. I'm going to show you guys. But 4 by 4 is 16, correct? If you turn it into unit squares, that means 1 unit squares, 1 unit, 1 unit, 1 unit, there are 16 units altogether. And what fraction of it is shaded? The answer would be, right, 16 minus 1, 2, 3, right? There's 1, 2, and 3 here. That's unshaded. So the answer for part A is simply, okay, I'm going to write down here, okay? So that's easier for you. Oh no, there's no space. I'm just going to write here, okay? So it's just 13. 16 minus 3 will give you what? 13. Correct? So 13 over 16 is the answer for part A. Okay, just in case you want to like do it another way, it will be 4 by 4. Because why? There's 2, 3, 4. On each side of a square, 4 times 4 equals to 16 squares altogether. 16 cm squared, right? But in this case, it will be units because there's no cm given. Okay, part A done. Okay, simple. Now, part B. Figure Y is made up of 4 such triangles. So this figure over here is made up of 4 of them, right? So you can see the whole thing just now we're just going to put it in. The area of the unshaded part of figure Y, okay, be careful, this now is unshaded. This is what they try to mess with you guys, right? It's 81 square centimeters. Question is what? What is the total area of the shaded parts in figure Y? Okay, so what is the total area of the shaded parts? They want to find the shaded parts now. So, you see, remember just now we told you that, I told you that it's about units and not cm so far, but now they put in the cm squared. So, unshaded part is 81 cm squared. So, if you remember, this is 3 out of 16, correct? So, it's like 3 parts. 3 parts here, 3 parts here, 3 parts here, because they're all equal. So, 3 by 4, right? 3 times 4 is equal to 12. So, there are 12 units of unshaded parts, right? So if those 12 parts unshaded, right, are equal to 81 square centimeters, can we find one? Yes, we can. Okay, so let's do 12 units is equal. Okay, let's not use units because the previous one was actually units, right? So I'm just going to put right on there 12 squares. Okay, 12 squares is how many again? 81. Yes, 81 square centimeter. So 1 square is going to be what? 81 square centimeter divided by 12. Now you might be asking me, hey, but that does not sound right. There's no, multiple of 12. There's 81. Use your calculator. Okay, so the answer will be 6.75 square centimeters. Okay, it's not always a beautiful number, not a very nice number. Okay, so question, they ask you what is the total area of the shaded parts. So remember just now that we had already established how many, right? So for this case, I'm just going to use the easier method, which is I'm going to take the whole number, right? The whole thing is how many? If you remember, there was 16, right? 16 times 4. What is 16 times 4? I repeat one more time. The total for each one was 16, remember, 4 by 4. So 16 times 4 of these would be 64. There are 64 units altogether, 64 squares. You minus off the unshaded parts, which is 12. So 64 minus 12 will give you 54. So these are the shaded parts. Clear? So the shaded parts are 54. And now all we have to do is multiply, not 54, I'm sorry, I made a careless mistake. 52, thank God I caught that. Okay, so 52. So 52, all you do is multiply by the value or the area of 1 square. So 52 multiplied by 6.75. Okay, so that will be the final step, which gives you 351 square centimeters. Alright, there you go. Done. That was easy. The question that has tortured a lot of children. Okay, so this question says Mr. Tan packed 508 tarts into large and small boxes to sell. He filled each large box with 20 tarts and each small box with 12 tarts. So there's 20 tarts for this one, right? And there's 12 tarts for this one. And the question asks you, what was the least number of boxes used by Mr. Tan, and if all the boxes were full. Now this is important. All the boxes were full. It's giving us a clue as to how to do this, and that there was no tart left over, so there's no remainder. Yeah. So the way I see this, right, is if you want to get the least number of boxes used, right, you will need to pack as many cupcakes into the large boxes as possible. Because when you do that, then you will have the least remainder to be packed into the small box. As opposed to packing everything into small boxes, then you're going to have a lot more boxes as compared to doing the former. Okay, so what we're going to do right now is we are going to ask ourselves, what is the maximum number of large boxes that we can do, put the cupcakes into, right? So I know number 508, right? The closest number will be, which is a multiple of 20, will be 500, correct? So what I'm going to do is, I'm going to do this. 508 divided by 20. Oh, what happened? 508 divided by 20 is going to give me how many? 25 boxes, correct? 25 boxes with a remainder of 8. Yes. So in this case, right, what happens is that I have a remainder of 8. Can I pack that remainder of 8 cupcakes into the small box of 12 without a remainder? Answer is no. So what I'm looking for essentially is I'm looking for a remainder which is a multiple of 12, right? So I just keep going. So what about if it's not 25 boxes, is it 24 boxes? So what is 24 times 20? 24 times if boxes got, each box got 20, that means that will give you 480 cupcakes. So what's the remainder there? It will be 508 divided by, why is this happening? 508 divided by, oh man, sorry, not divided by, minus 480, and the remainder would be, I'm so sorry about this, guys, 480, let me just bring this down in case maybe that's the reason why. Okay, 480 equals to 28, right? Equals 28. Now this is not a multiple of 12. So we're gonna keep going until we have a multiple of 12, because I really give it a shot and find out if I can do this using assumption method, right? I previously had mentioned that any guess and check question can be attempted using the assumption method. My statement is wrong. Yeah, I was wrong basically. So for this particular case, I cannot use assumption method. I have to use the guess and check method. So which is why we just keep going by trial and error until we get a number that is a multiple of 12. So let's keep going. The next one, let's say if it's not 48, is it 46? Okay, let's give it a shot. Not 46. Is it 20? Not 28. Sorry, I'm a bit lost here. 24 boxes, right? The large one. Let's try 23 boxes. 23 times 20 will give you 460. Alright, 460. So 460 means that there will be a remainder of 508 minus 460, which gives me 48. There you go. So we now have a multiple of 12, right? Now what does that mean? It means that we will need here 23 large boxes. Let's write it down first. 23 large boxes, okay? And there's 48 remainder to be packed into the small box. So 48 remainder divided by 12. That means there are going to be 4 small boxes. Simple. So the answer will just be 23 plus 4. 27. So this is how we do these kind of questions. Sometimes we just have to guess and check, and there's no other way about it. Alright? Good. Alright. Now we're going to go into this question for volume. Now this question is a very, very important question that your child needs to know, because it's about the volume of water being transferred from one to another container and then resulting in an equal height. Okay, so just to give you guys basically an idea, an overview, right, of this is X and Y are two rectangular containers. The base area of X is 30 square centimeters. Okay, let's put that in. That is 30 square centimeters. Alright. And the base of Y has dimensions as shown. So 30 by 9. So straight away, I'm just going to find out what is that. 30 by 9 will give me 270 cubic centimeters. Sorry, squared centimeters. So here's with 270 centimeters squared, right? Okay, so we have one that's 30 square centimeters. We have one that is 270 square centimeters. Now the question says that X contained 780 cubic centimeters of water, and it says here and Y was empty. What was the height of the water level in X? Now for the first one, it's going to be quite straightforward, right? The idea here is this. The idea here is that if volume equals to length times breadth times height, right? That means that height is going to be volume divided by length times breadth, okay? So the idea here is that length times breadth is actually the base area. So base area is what we already have found, right? So it's very simple to do this. All we have to do is just divide, right, the volume of water by the base area. So let's just do that right now. 780 divided by 30. That was really easy, wasn't it? Right? So that is just the answer of 26 centimeters. Okay, so that's the answer for the first one. Okay, part A, done. Now let's go through part B. Now part B says Sam poured some water from X into Y without spilling. In other words, right, the water goes in and there's none that is that's unaccounted for, right? So after that, the height of the water level of X was the same as that of Y. Now this is an important information. They tell us basically that the resulting height are the same, right? So I'm just going to show you what that means. Okay, so let's say, okay, let me show you. Slide that right. Okay. Oh, this is nice. I love this. Okay, so let's say that's the height over there, right? Okay, now if after being poured, it's going to be slightly lower, let's say around here. Okay, now the water level on the other side is also going to be the same, right? So let's draw that one as well. Okay, I think this is a bit off, but never mind. I'm enjoying this drawing thing. Okay, so let's make it about, okay, it's roughly about the same height lah. Okay, so give and take. So as you can see, right, when the water level becomes equal, there is actually a formula to it. Now, do you know that? The formula is very simple. The formula that we have told the kids is this, right? We said that if you want to find two things that are equal height, all you have to do is take the volume, right, divided by the combined base area. Combined base area. So in this case, what is the combined base area? 30 cm squared plus 270. So let's do that. 30 plus 270. That is 300 cm squared. Okay, square centimeters. Now what we need to do is we take the volume, which is 780, divide by 300. I have no idea why my handwriting is very bad. I've changed my software to a better one for the recording, but it's really laggy right now. So anyway, the answer here would be 2.6 centimeters. So the idea is that if you combine both of these figures together, right, what happens is they become one particular shape and the water level would sink to match both of their combined base area. So the answer for this one is 2.6 centimeters, and that, however, is not the final answer. So a lot of kids will stop there. You have to tell your kids to always ask themselves, what is the question asking for? So in this case, how much water did Sam pour into Y? Water, not height. So if Sam has poured the water into Y, right, that means the height here must now be what? 2.6 centimeters. Same goes for the one in X, is 2.6 centimeters. Clear? So therefore, to find the volume of water that's been poured into Y, we just need to do what? Length times breadth times height. We already have the base area times the height. So the answer here would just be 270 multiplied by 2.6. Okay? So the answer here is 702 square centimeters. Done. Alright guys, we have arrived at the last question. Ha 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 ha. I'm so happy. I hope you are too. Okay, number 17. In a shop, candles are sold only in boxes. So remember, they don't sell it by in ones, right? In like one pieces, they sell it in boxes. A box of 7 short candles costs $2.50 as shown here, and a box of 5 long candles costs $3.20 as shown here. So Dan, my friend Dan the man, wants 19 short and 3 long candles for his lanterns. It's lantern festival, guys. Actually, I'm talking about it right now. I saw a bunch of people playing with lanterns. I think it's the lantern festival in Singapore. Yeah. Anyway, I got distracted. What is the least amount of money? Least amount of money that Dan will need to spend on the candles. Okay, quite simple, right? So if 19 short candles, okay, this is the one. Okay, so you can only buy it in boxes. So multiples of 7. 7, 14. Okay, is it enough 2 boxes? Not enough. You gotta buy the third one, 21. You will have excess, but it's okay, right? You can use it for the next year. So 7, 14, and 21, it means that you need 3 boxes. So what's 3 boxes of that? That will be 3 multiplied by what? $2.50. Okay. Now same thing here. Box of long candles, you need 5. So you cannot buy none. So you need 1 box. So you need 1 box of 5. So therefore, all we have to do now is just calculate how much the total value is. Now, if you want to do the working, right, it's just going to be like this. Okay, 19 divided by what? 7 candles will give you 2 remainder 5. Right? 2 remainder 5 means that you need an extra box. So 2 plus 1 more box will give you 3 boxes. So 3 multiplied by 250 will give you $7.50. Okay, that's for the short candles. For this one, no explanation required. I'm just going to plus $3.20, right? So the answer for part A is just $7.50 plus, oops, sorry about that, plus $3.20. So the answer to part A is $10.70. All right, done. Part B. Ava bought 21 more long candles than short candles. So Ava bought 21 more long than short. The total number of candles she bought was fewer than 50. So, important note, total number is fewer than 50. How much did Ava spend on the candles altogether? Okay, so we have to find out, first of all, how do we get a number that's 21 more long than short? Okay, so I'm going to do it this way, okay? Guys, take a look, okay? I'm going to do it this way. If there's 21 more long, that means that I will need to buy at least how many? 5, 10, 15, 20, 25. I will need more than that, right? So because 25 minus one box of 7, that's still less than 21. So I'm going to keep going. 30. Okay, let's stop at 30 for a while. 30 minus 7 will give you what? 23. We are close to the answer, but not the answer itself. If it's 30 minus 14, that will be what? That will be 16. Still cannot. So which means that I need to bring up the number of long candles. Let's try the next multiple of 5, which is 35. 35 minus 7 is what? We're getting very close actually. 28, right? 35 minus 14. Oh, there you go. 35 minus 14 is 21. Yeah. So there you go. That's how I did this question. 35 minus 14. So how many boxes is that? 7, right? 35 divided by 5 is 7. Then of course this is 14. So that's the answer right there. So just for the working, I am just going to write down. Okay, hold on a second. I'm just going to write down 35 sorry, I knew it. The color has changed. 35 minus 14 is equal to 21. Correct? Yes. So now all I have to do is find out the cost, right? The price. So how much did Eva spend? Here will be 14, it means 2 boxes of short candles. So that will be 250 multiplied by 5. Sorry, multiplied by 2, my mistake. Equals to $5. Right? So that's for the short candles. For the long candles, 1, 2, 3, 4, 5, 6, 7. 7 boxes. So therefore we got $3.20 multiplied by 7. And what's the answer? Use your calculator. You will get $22.40. So the last step is just to add up the two together. We take $5 plus 24 plus $22.40 will give us the answer of $27.40. And with that, woohoo! We have completed the whole of the 2018 paper, and I hope that you have found my explanations helpful, and I hope that you have managed to get a lot out of these video recordings. With that is Coach Saiful signing off. Live with courage.